Today we're going to be taking a look at the Elegoo Centauri Carbon, a machine that promises high-end features at an incredible price. But does this printer actually live up to the hype? We're going to start by getting this machine out of the box. This printer was very kindly sent over by Elegoo for me to test out, but you know how we run things on this channel, I always just want to give you all a realistic look at what these machines are capable of creating. With this being a fully enclosed style 3D printer, there's really not a whole lot of setup involved, so while I work on getting this thing out of the box, let's talk about the specs of this machine. The Centauri Carbon has a 256mm cubed build volume, auto bed leveling, a filament runout sensor, USB and Wi-Fi printing, built-in camera, and due to it being an enclosed printer, you have the ability to print any type of filament you could possibly want on it. So far this setup process has just been removing a bunch of packaging, but now it's time to grab the accessory pack for the included tool so that we can work on unscrewing the bolts that hold the bed in place during shipping. There are 3 of them, and they are labeled with some red arrow stickers so that you can more easily locate them. After that, it's on to installing the screen. First, we're going to remove the tape holding the cable in place, before then plugging that cable into the back of the screen. It then attaches to the printer by inserting the clips onto the mounting slots and sliding the whole case downwards to lock it in place. Something that was a pretty cool feature to see on this printer is it's actually packaged with a double-sided build plate. The first side is the more standard textured PEI plate, and the back side is a PLA specific plate with an even smoother texture. After that, there were just a few more bits of packaging to remove that were more within the printer itself, but then all that was left for assembly was adding the spool holder onto the side of the printer, adding the glass top to the machine if you want, and then finally plugging the machine in and turning it on. So yeah, really straightforward and simple setup. Took me like all of 10 minutes, but now it's on to getting this printer calibrated to be ready for printing. The machine makes sure that you've already removed the bolts and any of the other packaging within the printer before starting its self-check routine. As you can see from the list, it's all of the pretty basic things, just making sure that everything is working properly before moving on to input shaping and then bed leveling. And that's setup complete. After that, I did add my printer to my Wi-Fi network and then check for any firmware updates, which there was, so I got that installing. After that had completed, it was on to getting this thing printing. First, we need to load some filament though. To do that, you go into the control settings to extruder, you select the temperature that best suits the material that you're printing in, press load, it will heat up the nozzle, and then you can just go ahead and insert the filament into the filament runout sensor and through the PTFE tube. From there, the extruder will grab the filament, extrude a little bit of it, and then clean the nozzle off so that you're all ready for printing. For my first print, I decided to start with a very exciting waste collector bin. The Centauri Carbon has that fairly typical poop chute design, so printing something to collect the blobs of filament is always a good idea. For this print, and actually the majority of prints in this video, I left pretty much all of the settings as is. The only things I ever ended up modifying were walls, infill, and the occasional nozzle temperature. And I have to say, everything seems pretty dialed in with this machine, because an hour and 41 minutes later, I had a flawless looking waste chute in my hands. I printed it in this galaxy black filament because I thought it would complement the color of the machine itself, and it really doesn't get much more flawless looking on a 3D print than this. I mean, you pretty much can't see a single layer line on this entire print job. It doesn't even look 3D printed. This particular chute design has holes to install some magnets into so that you can just magnetize it onto the back of the printer. After such a great looking first print, I was feeling pretty confident in this machine, so I decided to go full speed ahead into a life-size droid head print out of ABS. Would you expect anything less from me? No, but really, I wanted to see how this printer would handle something like ABS because I know a lot of you are interested in starting to use these harder to print materials, and the only thing standing in the way is access to an enclosed printer. With the Centauri Carbon being like half of the price of a lot of other enclosed machines on the market right now, I completely understand the interest in this machine, on top of all of the other great features that it includes. All of these were parts for an SM33 head from Skeleton Crew, and as you've been seeing in all of this footage, the Centauri Carbon was handling ABS beautifully. I did start off with some of these smaller pieces and then eventually worked my way up to what is pretty much the majority of the head. It's like the full upper skull piece. It also works as a good example of showcasing the size of parts that you could fit on this machine. I do have to mention the nicks and dings and scratches that you see are literally part of the model. It's not like printing artifacts or anything. It is like a textured base, and overall I think this is a beautiful looking print. With this being a reasonably reasonably complex project with a lot of different pieces. It also gave me the opportunity to put a bunch of hours on this printer and also see if anything basically would trip it up between different shapes and different types of support material, and all of these prints were turning out great. I had no failures during this entire testing process, which wouldn't inherently be the machine's fault, but it's always nice to know that the machine is printing super reliably. And here's what all of those SM33 parts look like put together. There are still some pieces that are missing that I plan on resin printing in the future, but this is where the project stands as of right now. This was the point in my testing process where I decided to just basically start using this machine for anything that I needed 3D printed. First thing was a replacement bracket for a resin bottle to go on my pegboard. One of mine broke, I needed a new one, so why not have this machine printed? And this was also out of ABS. I then went back to using PLA and decided to print the scraper file that is included on the USB stick. I did end up reslicing it myself to better suit all of my personal preferences in terms of settings. The printer comes with the scraper blade and screws needed to complete this project, so got all of that installed using one of the hex keys that also comes with the printer. And now I have a nice scraper to sit alongside this machine. I am also a pretty big fan that it comes with a stand just for protection of the blade, but also for easy access. Next up, and also sticking with PLA, was a headphone stand that my dad requested. This was actually the closest I came to any sort of print failure on this machine. I didn't use a brim on it, which I should have, and it lifted off of the plate a bit, causing a couple of lines in the print, which is so unfortunate because other than those two areas, this thing was looking absolutely flawless. It's still a really great looking print though, and does the job perfectly well. Next up was another PLA print. This time, finally, we have some filament colors being introduced with this navy blue. It was apparently just one of those weeks where everything I needed printed, I needed it to be in black. Except this vase, at least for right now. And this thing turned out so cool looking. This is like the first sort of vase I've actually ever printed. But something between the design of this vase and also the matte filament, this thing just did not look 3D printed. You could not see a single layer line on it. And this vase wasn't just for any flowers, but some of the Lego ones. I think this is the wildflower set. But yeah, while it is simple, it is a very impressive looking 3D print. Next, I switched over to some PETG to test on this machine. Not that I wasn't expecting the Centauri carbon to be able to handle it. If anything, it ends up being a test for how much PETG likes sticking to the build plate, and in some cases that is it sticking too well, but I'm very happy to report that it was just right in this case, and I didn't have to bust out the scraper that I printed in order to get these prints off. And both of these prints were a couple of options of various tattoo ink cup holders. I know, it's very random, but I've been using a lot of tattoo ink cups for painting recently. They are absolutely perfect for putting a little bit of paint in, and instead of having a bunch of them just stuck around on my desk, I thought it might be good to have a holder for them, and this did the perfect job of that. For my last test print, I really wanted to try and max out the print volume of this machine, so I decided to go with this Ventress Bounty Hunter helmet. It's a more skull-style helmet or mask, so it just fits in one piece on this printer. Something that I haven't had the chance to really talk about at all in this video yet is in any of these clips where you can actually see the print well within the machine, it's because I have this really strong photography light bar sitting on top of the glass door. My cameras are also trying to balance out the color and shadows because without it, and still with that balancing of the cameras, it looks something like this. And keep in mind, this is with silver filament, so it's a pretty light color. If it was black or any darker filament color, it would just be like staring into a dark void. I'll be talking even more about the lighting situation in the end part of the video, but back to this helmet, it turned out beautifully. Such an impressive looking print. I'm so glad that I was able to fit this in one piece on this machine. And here's what it looks like off of the build plate. Such a clean print. The support material all printed successfully. I also did the trick where you don't actually support the inside of the helmet since it will complete itself going around in a circle, and even though that was a very intense overhang, that again looks like it printed really cleanly, like it really doesn't get much more clean than that. The support material also was coming off really easily, which was the case for all of the prints. I just haven't had a chance to mention it until now. So the cooling fans are working great on this printer. And here's what the helmet was looking like after all of the support material was removed, and I added on that separate mouthpiece print. Just a gorgeous looking ABS piece that I am obviously in the future going to be doing a lot of painting to, but even right now it just looks so cool. Overall, it's been a very positive few weeks with the Centauri Carbon. The prints have been turning out beautifully, and it's proven itself as a very capable 3D printer. I think a big pull to this printer is going to be because of its enclosed design and the printing possibilities that opens up in terms of materials. I know you've all become used to seeing me using ABS all of the time for my prop build since it's so much easier to post-process, and I constantly am getting comments about how people wish they could be using ABS in their work as well, but they just don't have the printer that would be good at handling ABS. For ABS and even ASA, using an enclosed printer is pretty necessary. You want to make sure that the printing environment is staying at a reliable and also higher temperature for the prints to be successful. So with the Centauri Carbon being an enclosed style machine and also one at a very reasonable price point, then I can see exactly why this is going to be a great option for a ton of people that have been looking at jumping into printing with some of those harder to work with materials. And honestly, even outside of that, it has just been a really great printer to use. And while I have had a great experience with using this machine over the past few weeks and testing it out, as with all 3D printers, it does have its pros and cons. Probably the biggest challenge that I had with this printer is thankfully something that in the grand scheme of things is pretty minor, and that is just how dark it is inside of the printer, even when the light is on. Now, for a lot of people, this might be a non-issue, but if you are looking at printing something like ABS and you have to keep the printer fully enclosed, you can't just pop the door open and take a look inside, it can become pretty difficult to see if anything is going wrong on the print job. It also doesn't really help that the glass is tinted, because I would have to either take my phone flashlight or one of my filming lights and put it up against the glass to be able to see if anything was going on the inside that maybe shouldn't have been. Checking that first layer is going down nicely and other things that the camera on the inside wouldn't necessarily be able to capture. It becomes even more difficult if you are somebody that frequents dark filament colors. I think this was the first time testing a printer where I really noticed how many dark filaments I typically apparently use all of the time, and that it was going to be an issue, especially for filming this video and having the footage actually look like anything other than just a dark blob. That was actually one of the main reasons why I chose to print that Ventures helmet, because I knew it would look good in silver, even though I typically probably would have used black for it. So yeah, I know this is going to be a bit of a hit or miss point in terms of how important everyone thinks the lighting in a machine is, because yeah, obviously the most important thing is that the printer is actually functioning okay, and it is. The lighting isn't changing that, but it can start to make the user experience a bit more difficult because it can become so difficult to see inside the printer. I just wish that the machine lighting was more of an LED bar along the front or side of the machine instead of just the single light that is above the camera. And this could even be something that gets solved by the community in terms of adding some sort of LED bar and running it through the machine that it's not affecting the enclosure. The Centauri Carbon doesn't have any chamber heating, but it also isn't the largest machine, so it seems to be doing a good enough job at keeping its internal temperature high enough for ABS at least to be successful on. The chamber temperature was reading about 36 to 37 degrees Celsius, which is definitely colder than I would like to be printing ABS at, but again, everything did end up turning out fine, so it was obviously warm enough for at least the parts that I was printing. But with the chamber only staying around that 37 degrees Celsius mark, it does seem to be that those metal side panels aren't necessarily doing the greatest job at keeping the heat in. I guess I just would have expected when you're running 100 degrees Celsius bed for the internal chamber temperature to be a little bit higher than that. But it also doesn't seem to be an issue, at least for what I am going to be typically printing, and I guess overall that is the important thing. I did sort of briefly touch on the camera, but it is marketed as being your eyes in the machine when you have the printer fully enclosed. The problem, at least right now, is the camera really will not hold a live stream. Now, I know for sure this is definitely not an internet issue for me. I mean, I have so many other printers and cameras and everything else, and they're all working fine. When I at least go to view the camera stream from the fluid interface, it will show like maybe 1 to 4 seconds of live stream before it like cuts out and it does the whole little question mark in the middle of the screen sort of situation. Now, I'm not entirely sure if this is like a printer processing thing, if this is just its interface thing at the moment and it could be completely fixed with a future firmware update, but whatever it is, right now it's not great. I mean, it can do the job if you're just wanting to take a look at the printer, make sure that none of your print is failing, you know, everything's looking okay, but you might have to like refresh the page a couple of times to get a really decent look at whether your print is failing or not. Really hoping that that is something that can be improved on with future firmware updates, but I guess we will find out. Another thing that absolutely needs to be updated is the machine start G-code. Right now the startup G-code has the machine starting the print job, whether or not if the bed has reached the set temperature or not. It's not the most severe when you're looking at printing PLA. I have in my notes that it started when the bed was around 48 degrees Celsius. 48 degrees Celsius to 60 degrees Celsius is still a pretty big jump, but that would get even worse when you look at printing PETG or ABS. Assuming that the whole startup process takes roughly around the same time, even if you're looking at the nozzle needing to hit a bit of a higher temperature, you would end up in a situation where the bed is possibly only at like maybe 55 degrees Celsius when it's supposed to be at like 100 if you're printing ABS. And yes, this is something that you could go into the startup G-code in your slicer and modify yourself, but just in general, this is something that needs to not be happening and fixed for everyone, regardless of knowledge and experience as to how to possibly modify this startup G-code so that it doesn't end up doing this. Even by the time you're watching this video, this is possibly an update that's already been implemented, and this is hopefully no longer an issue. Another thing that I noticed is the bed probing seems to be pretty inconsistent. It seems to be doing a perfectly fine job at bed leveling in the end. It's just a little maddening to watch happen when, for seemingly no rhyme or reason, it sometimes takes 1 time to probe the spot and sometimes takes 8 times. Just one of those things that I wanted to mention in this video in case you are somebody that ends up with this machine and is sort of losing their mind and wondering why on earth this printer is doing this slightly weird behavior. It just seems to be maybe one of those little quirks about this printer. Another inconsistent thing are the VFAs, which are vertical fine artifacts. For anyone that's never heard that term, they are those pretty even ripples that you can sometimes see on the sides of prints, and they are generally caused by motor vibrations. Not the vibrations of the machine itself. It's not something that input shaping is supposed to be able to counteract. It is one of those things that technically has the possibility of showing up on any 3D printer, and the whole reason I'm even mentioning it in this video is because of, again, the inconsistencies with it. I realized that the only prints that actually showed any form of VFAs were the ABS ones, and that is when I slowed down the print speed, which I would not say should be the norm in terms of when VFAs would start showing up. But I mean, like, even on the Ventress helmet, it's inconsistent on the single print job. The right side of the helmet shows it significantly more than the left side. I mean, like, the left side of that thing is absolutely flawless. So it's just really the inconsistencies of it all that's kind of mind-boggling and I guess somewhat interesting. I do have to say though, even on the side that shows it a little more, I still think looks really good, especially if you are looking at this machine being like a prop building printer for you, and all of the pieces that it's going to be producing you're going to end up sanding and painting later. Then any minor VFAs on the prints are going to be a non-issue because it's going to go through a ton of post-processing that's going to eliminate them all. And like I said, even the rougher side of that print still looks pretty incredible. It's just a little odd because it never ended up showing up on any of the PLA pieces. I mean, you've seen them. They looked absolutely flawless. I printed so many straight flat things, which would generally be where you would start seeing VFAs show up more, just because it doesn't have any sort of texture that would then be able to hide any imperfections like that. I am really interested in printing even more ABS pieces on this machine and seeing if just tweaking the speed settings by like 5 or 10 millimeters a second will all of a sudden magically make the VFAs disappear. It could just be some weird thing that the speed settings that I'm normally printing ABS at just do not like meshing well with these motors. Just one of those points that I wanted to mention in this video for the sake of information purposes, and you personally can make the judgment call in terms of how important that is for you. Because even on those ABS pieces that have those more visible VFAs, I still think they look like really great prints, and I think for a lot of people they're going to look like really clean, excellent prints. And overall, the print quality that I was able able to achieve on the Centauri Carbon was incredible. The ABS pieces, definitely some of the cleanest ABS pieces I've seen. They always have the tendency of looking possibly a little messier than PLA or PETG prints, just because you're not using the same cooling settings that will make the surface finish absolutely flawless. But I personally was pretty happy with how all of the ABS parts turned out. And I mean, you've seen the various other PLA pieces in this video, just such clean, flawless looking prints. Honestly, hardly looked 3D printed. You basically couldn't see a single layer line on them. And that was also with majority default settings. It's again one of those things where the only things that I was tinkering with were walls, infill, and the occasional temperature change just to better suit the filament that I was using. This machine is very much plug and play, no tinkering, just removing a few screws, making sure a couple of things are installed, and you're good to get printing. I really like the sleek design of this printer. The only thing that was a little bit of concern was the filament holder on the side. A plus for placement, I do have to say that it's not on the back of the machine, so good on Elegoo for putting it on the side of the printer. But with the spool holder adapter just being on that metal side panel, it does have a little bit of give to it, so I wish the design possibly had the holder being more directly attached to the base of the machine just to stabilize it a bit more. It doesn't seem to have ever really been an issue, but I do wonder if over time the panel starts like pulling out more and deforming a bit because of the possibility of being like a kilogram of filament on the side of that machine. Like, I would say absolutely do not put anything heavier than a kilogram on it. I know some people print custom spool holders to put larger filament spools on their printers, and I would say if you are someone that's using larger and heavier filament rolls to completely like just make another filament holder, don't try and just directly attach it to the side, because I think that would definitely warp the side panel out of shape. I also really like the double-sided build plate design. Most printers these days ship with some sort of a textured PEI plate like side A is, but sometimes depending on what you're printing, you do really want that bottom surface to be significantly smoother than that textured plate will allow. So having it be a dual-sided build plate where you have that option of flipping between the two sides depending on what you want your finished piece to look like, I am a big fan of. I am also a big fan of the fact that even though this printer has like barely been released, there's already replacement parts available. Now, I would definitely like to see even more replacement parts become available, but there being replacement hot ends, like the full assembly, is a great start. From there, I would like to start seeing replacements for the hot end fans, since they are the ones that are possibly in the most danger of needing replacements in the future. You know, if you had any sort of print failure that sort of like took out the whole hot end, you would possibly need to be replacing those fans as well. And if they have any sort of custom connectors on them that are very machine specific, then you're gonna need replacements for those. But I'm glad to see that there's full hot end assemblies, and I hope to see even more replacement parts in the future. Overall, I think the Centauri Carbon is definitely a 3D printer worth considering, especially if you're somebody that's been looking into an enclosed machine to start printing with some of those harder to work with materials. The print quality to price ratio of this printer is pretty hard to beat, especially with it being fully enclosed and the material capabilities that it has. Normally fully enclosed printers are at least like 1.5 times, if not double, the price of this machine. I should also mention, if you are somebody that's not super bothered with it being an enclosed printer, Elegoo has also come out with the Centauri, which from my understanding is the exact same machine minus the side panels and glass doors, and it's even less expensive than this Carbon version. So if you like everything about this printer but don't see yourself needing it to be enclosed, then that is an option as well. As always, if you want to find out even more information about the Elegoo Centauri Carbon, there will be links in the description box, as well as links to any of the models you saw me printing in this video. But that is everything, so thank you so much for watching, and I will see you in my next video.